All right, everybody, welcome back to the shop. We're getting ready to start our next job. Let me show you what we're going to do. This is going to be I'm collaborating with Flexarm on this job right there. And Nick over there had contacted me and asked me if I would be interested in kind of working and collaborating with them on a bigger project that they're working on. They're actually working with a company called Launcher and building a large fixture with the Flexarm on it to do a bunch of power tapping on some 3D printed components that Launcher is going to be building. So this is just one simple part there that Nick thought that I might be interested in helping them out with. So he sent me over the print here, and I told him, I said, absolutely, we can do that. That's right up our alley here. Shouldn't be that bad. So what we are going to be building is a tap adapter for the Flexarm machine that's going to be going from an 1.5" NPT tap up to a 2" NPT tap. All right. Unfortunately, at the moment, I do not have one of those tap holders. This is an example of the tap holder that will be used in the machine. Now, this is for 1.5", just a regular bolt tap. So, like this guy right here, this 1.5" tap. So, it fits in there like that, just like so. But like I said, this one right there is for regular, national course, national fine 1.5" bolt taps right there. All right, what they're going to be using is the NPT holder, which I don't have, but I talked to Nick and he's actually going to be sending me one today. So I'm hoping by maybe even tomorrow I will have this actual holder in my hand so that we can test fit this part that we're going to be building right there. That's what it's going to look like. So this shank right here is actually going to mimic the 1.5" NPT shank of a tap. So this will fit the holder here. All right, and then this portion of the adapter here is going to be machined to fit the shank of a 2" NPT tap. All right, so that's the idea behind it right there. So they've already done all the hard work for me by getting the dimensions that I need. I verified it with the shanks of my old NPT taps right here. And these are two more of the 2" taps, and I was just verifying the dimensions of everything. All right, so that's what we're going to be doing. And I've got a little printout here of another picture that I was looking at that Nick had sent me. So this is the idea behind what Flexarm is building right there. They're building this fixture with one of the flex arms that Launcher will be using to be tapping these housings that they 3D print. And from what I have read, they've got a website, Launcherspace.com. They're building 3D printed housings or for satellite use and small rockets, go up into space. So it's pretty cool to have a little piece, of the action here in this project. And there's a possibility that maybe I could work with all these guys in the future on maybe doing some other machining on maybe even, a part like that's going to go up into space. So pretty exciting about that. But for now, we're going to go ahead and just work on our tap adapter. I just wanted to show you guys, how this is going to be used out there in the field. This is still in development. The guys are building this right now. So, just a simple part that we can make and collaborate with Flexarm on. So we're going to be using this piece of 4140 right here. And I think that was some 3". Let's see. Yeah, well, it's a little over 3". A little over 3". 4140. That's what we're going to machine it out of. I actually got this piece of material from Micah over at A&E Machine and Gear out there in Dallas, Texas, whenever I was visiting him with Andrew. He had a little stack of these out there, and I asked him if I could have one. He said, yeah, take one. So that's where it come from. And I don't know, how hard it is. Hopefully it's going to be the good heat-treated stuff. So we're going to go to the Monarch lathe and do all of our turning. We'll go to the mill. We got some mill work to do on the square shanks, on the internal square. So a lot of good machining. Let's go ahead and get started on it. All right, we've already got our workpiece chucked in the forge all here. We've already got it indicated in, and we're going to go ahead and start turning. We're going to do our facing op, and then we'll start turning here. I'm going to have to set the center height of this tool because I just stuck it in there. Let's see where it's at. Looks like I'm already on it. Oh, just a touch low. good right there. We'll lock her in. Good. That looks like that's going to be some of that good heat treated 4140. Let's try 250 there on the depth. Looking pretty good. Go in with a little bit more coolant there. I'm going to kick up the feed. That was at 15. This is 17. Let's see how it does that. Well, sometimes you just don't get it to start the way you want it to. Let me get my pliers. Get it to break off now. It's actually not breaking as good as it was before with a faster feed. Drop it down one and see if that works. Nope. I'm gonna have to add more feed to it, I think. It's crazy. That first one did great. 20. More like it. More feed. That's what we needed. All right, we've got the shank area roughed in right here. Now we're going to go ahead and roughen this. So, you know, it's around 3 inch, 150 or so. This is going to finish out 2.5. So we've got a couple of good roughing passes to make right here. I've already got a stop location set. Got a 0 set there on the dial, so we're ready to start turning. Got the roughing passes out of the way, so we're just going to go ahead and bring it on down using a different insert there. Alright, we're just finishing out our last pass. That's going to be the finished. I'm going to leave it there. So I've got approximately 40 thousandths on the OD, and I'll come in there and we'll cut that angle there as well. And then once we get that, the chamfer done on both edges, I'm going to go to the bandsaw and cut that off. All right, we've got our compound swiveled around 135 degrees, and we're going to go ahead and cut this little angular section right there. That was actually missing on the print right here, but they verified it for me. I've got another drawing right there. You can see it. So we've got it set up, and we'll get that cut in. I'm just about done with our lathe work here on the Monarch. All right, I think that'll work. I'll have to touch that up again once we get over to the Victor lathe to do our finish turning on it, but should be no issue. We'll go ahead and chamfer this corner here with another tool, and we'll be ready to take this out and go cut it off in a bandsaw. there's our part right there. I just like washing the chips and the coolant off of it. And so our next thing is we need to go ahead and get that end face, or we'll get our total face length finished up, get it faced off, and then from there I plan on going to the milling machine and I'm going to put the 4 holes in it that will allow me to help mill that internal square. That's probably going to be the most difficult part of the job, but that's where we're going to go next. We'll get the face done, we'll go to the mill, drill the 4 holes, and then we'll go back to the lathe to do our inner bore that we need to do. All right. All right, guys, I got the tap adapter chucked up in this 3-jaw chuck, nice and tight. We're going to go ahead and center it up. So what we're going to do here is go ahead and drill our 4 holes, which is going to be the corner of the square that we got to mill out down inside there. And I'm going to go ahead and just drill them now. And I'd rather do that now and then deal with the interruptions when I'm boring it versus trying to come in here with some long end mill and trying to cut that radius down that bore, because it's going to be intersecting the bore there. All right, I'm going to use this Blake coax indicator to find the center of it. I'm going to use this little Noga arm here as a stop for the rod, just like that. I just kind of eyeballed the center of it, so looks like we're off quite a bit. We'll go ahead and start getting it moved around. All right, so that looks like it's 1/2 thousandths off. We'll go ahead and zero our DRO up here. All right, and we're ready to start drilling. I just looked at the print to verify, so what we've got is equally spaced 1¼ inch both directions. So starting from 0, our 4 positions are going to be 625 in both X and Y position there. So we are ready to, I'm just going to spot all 4 of them with this little stubby drill. Just like that. And then once we get them all spotted, I'll go back and with a regular drill, length drill, and go ahead and drill them in. I think I'm going to speed it up. 1 position on the belt here. We'll go up to 1115. 625, 625. Just like that, and then all right, just getting my little cool mist set up right here to keep the drill bit cool. By the way, I went ahead and touched off on the face of the part and moved back over to my divot because we have a depth of 2.100. Let me check that again. 2.1 inches. Come on, I'm trying to get the coolant out of it. I think I need to take this nozzle apart and clean it. I've got this Michitoya readout on my quill, so works really good for doing depths like this. And just make sure that I had my drill good and tight in the chuck so it don't push back up in there. It's doing a really good job there. We're just about at our depth. Just sneaking up on it. There we go. All right. So let's go ahead and move over to our other position there. And I'm going to repeat this 3 more times like you saw. All right, up next we got to do our 2 counter bores. So I'll just go ahead and spot it in first, and then we'll get our other drill in there to get it drilled to depth. This is a 1 3/8 drill bit will go in there. So the deeper bore, which is going to be milled square for this square right there, is 1.410. So what we want to do is just bore it basically, you know, if you imagine a circle here, where the circle intersects the flats out there, that's the diameter that we're going to be boring to. And then we'll take the end mill and we'll finish milling it square over in the milling machine. And then the larger bore out here that will intersect the 4 holes is going to be this diameter right there, which I believe is going to be 1.875. Yeah, for this guy right there. All right. I just want to be sure that the drill is drilling close to size and not way over, so I usually just go in a little ways and check it. So 1.383, that's good. I know that I can bore it. It's not going to be oversized. I've got my boring bar with the depth established in there, and what I'm doing is I'm going ahead and I'm facing out the very back end and get the angle from the drilled hole out of there, and then we'll start getting the hole bored. I was just working on that, and it's kind of hard to show you that, so just kind of work it a little at a time. Right up to the bore of the hole. All right. So now I've got a flat bottom down in there that's actually bored to the proper depth as per the print. And then we'll face like 5/1000ths out of it just to kind of clean it up. So now we can go in there, touch this bore right here. It's going to take 10/1000ths and just clean that up, and then I'll mic it. See where I'm at. Should be very far off. Didn't have much to come out of it, so looks like I'm at 394. So we got 15 plus 1, so we got 16 thousandths to take out of it. get down to that bottom, I'm going to go ahead and face about 5/1000 to the center just to make it look clean there. Right here. Should be where we want it. See if I can get in there and look at that. Yeah, that looks pretty good. Give the bore a check. We're right on it. 410. All right, so we'll go ahead and do our counter bore at 1 7/8, and that one's going to be 1 inch deep. So what we'll do is we'll come back to the face here. I'm just gonna touch it, and I'm gonna reset my dial over here on this side. Just come up and touch it, and that one's gonna be 1 inch deep. Six, 7, 8, 9. We'll go 95. And that'll be our depth right there with 5/1000 to face out of. See if it'll handle 100/1000. Not a problem. It'll be 510. We'll go 610. All right, now we're getting into some interruptions. I'm going to slow that down. Backing off on the depth there, that's 50/1000 deep. And I think we'll go ahead and clear some of those chips out of there. Check where we're at on the diameter. Still got a little ways to go, so we're at 650. Another 150 to go. Using the Nova Cool to get it cooled down. Was pretty hot from all the drilling and boring there, so we've got about maybe 15/1000 to bring it to size. So once it cools down, and we'll do that, and then the lathe part will be done on this end. Once we get this counterboard done, get a chamfer on there, we'll be going back over here to the mill, start getting the square shanks milled on both the ID and the OD. We got the bore bored to exactly the print, 1.875. I'm just using one of my old taps right here, and I did notice there was some burrs there from turning on it for so many years. This is an old tap, but I dressed the burrs there, and I've got this to where it'll go in there just like that, so I know it should fit the shank just like it should there. So all I got left here to do is we're going to machine a chamfer on this corner, get rid of that sharp edge. Probably reach in there and do that one too. That one's really not necessary there, but chamfer it, and then we're going to go back to the mill to start our square, our internal square. All right, there's a shot of the lathe work, and I wanted to point that out. On the shank, you can see I actually spun just a little bit in the chuck jaws whenever I was pushing that 1 3/8 drill in there, and I was a little bit too aggressive with it, and it tried to spin. It didn't really mess it up, but you can see the rub marks on it right there. But that's exactly why I wanted to leave this just a little bit big, so that after I get through with all the heavy work, it's very simple to come to this 6 jaw right here and chuck each side of that and skin it down to the final dimension there without leaving a bunch of marks. But you know, that was just because of the heavy drilling that I was doing on it. All right, so we are ready to get back to the mill there, do our milling.